So the next topic in units and measurements, significant figures. All non-zeros, 1, 3.75, none of it is 0, can be considered as significant figure. So then therefore it's 4 significant figures. All zeros which exist between two non-zeros such as 1 and 5 should also be counted as significant. So there are 5 significant figures. Next, the zeros that follows can be ignored provided there is no unit. Okay, so then therefore that's got only 3 significant figures. That is, all zeros to the right are not significant. Next, when it comes with unit, see this is seconds or meters, then everything should be counted, and there are, therefore it comes with a unit, you have to count, and it has got 5 significant figures. And look at this, it's 161 centimeter, 3 significant figure. All zeros in the future, that is after, has to be counted provided there is unit and it's also a decimal number. So then therefore there are 3 decimal numbers. There are 4 in this, 3 in this, 4 in this, and 5 in this. The zeros in the past can be ignored even if it comes with a centimeter or meter or whatever, kilometer, whatever. So there are 3 significant figures and there are 3 in this. These are the rules you should follow while talking about significant figures. And rounding off, if the digit to be dropped is smaller than 5, then the preceding digit is left unchanged. See, if you have 23.45, if you're dropping off a 4, you can leave it unchanged. If you're dropping off a 6, you have to increase it by 5, increase it to 5. And dropping off a 5, then there are different cases. So if the digit to be dropped off is greater than 5, the preceding digit is increased by 1. If the digit to be dropped off happens to be 5, followed by, see, supposing 23.5456, if it's followed by a non-digit number, and if digit to be dropped happens to be 5, then you can increase the previous number by 1. Next is digit to be dropped is exactly 5. You have to check the previous number is an even number or an odd number. Even number, leave it unchanged. Odd number, increase it by 1. That's what I've written here. So first question is this example 64. It's coming with a meter, so everything is significant. So 4 significant figure. It's come with a kg, so 4 significant figure. Next one, this is zeros in the past can be ignored, so 2 significant figures only. Rounding off. Okay, so supposing they're asking you to round off 18.35 up to 3 digits. You're dropping off a 5 in that case. The previous number is an odd number, increase it by 1. The digit is to be rounded off to 4 units. And the digit to be dropped is 5. Check the previous number. If it's an even number, leave it unchanged. Suppose you are rounding off to 3 digits. There should be only 3 digits. So you can just write these as 0, 0, and you're dropping off a 6, so you can increase it by 1 because the number greater than 5. And you can't write 190 because 18967 and 190 means you have to add 2 zeros, and these are non-significant anyway. But just not a significant figure. It's about rounding off to 3 digits. So next is, in this you have to round off to 3 digits. 3 digits is just 1, 2, and 6. You're dropping off of 5, but there's a non-zero number next to it. So increase the previous number by 1. Rounding off to 3 digits, you should have only 248. The number that's getting dropped, 248, and your number that's getting dropped is 337. You have to round it off to 3 digits. So number that is getting dropped is only a 3, and so it will become 248,000 because it has to be closest to this value. You can't write 248 and leave it like this. Okay, so you have to include 3 zeros. Rounding off up to 5 digits. The number that's getting dropped is 5. The previous number is an odd number, so increase it by 1. So rounding off up to 4 digits. The number that is getting dropped is 5. The previous number is an odd number, so increase it by 1. The 10 to the power can be ignored, no problem. Okay, rounding off up to 4 digits. Because even if you're going to have so many zeros, there's no unit or anything, so it can be ignored. And zeros in the previous one, if 0.00 can be ignored. So you don't have to consider 10 to the power 6 or 10 to the power 5. So while rounding off, you can just take it and round it out 4 digits. The number that's getting dropped is 5, the previous number is 2, so leave it as it is. So while adding 3 quantities, you get the answer. The question will be express the result to an appropriate number of significant figure. You know the least significant figure is 2. The highest significant figure is 5. You, in addition and subtraction, you're not supposed to see that. Even though the question is significant figure, you should always check the least decimal place. Locate the minimal decimal number. It's got 2 decimal places. The 7.21 has got the least decimal place. And you have to round it off to least decimal place. Get the answer, round it off to least decimal place, which is 2 decimal place. You're dropping off a 3. Doesn't matter, just leave it like that, because number less than 5. During subtraction, you look at the least decimal place, which is 3, 807 is 3. So once you get the answer, just round it off to 3 decimal places. Or what is it, 4 decimal place. So 4 decimal place, a number that's getting dropped off is a 4, which is less than 5. So leave it as it is. The previous number, just don't change it. So you have to subtract these 2 numbers. One is 2 into 10 to the power minus 6. Another is 4 into 10 to the power minus 4. The first thing that you got to do, because you're subtracting, you make sure that you have a least decimal place. So then convert this into 10 to the power minus 4. Because we don't want maximum decimal place. We want always minimum decimal place, least decimal place. So convert this into 10 to the power minus 4. Once you convert it, you have a common power and you can subtract these two, you get this answer. And then again you have to round it to least decimal place only. And what was the least decimal place in this sum? There was just 1 decimal place, correct? So 1 decimal place. So you are dropping off a 9. So the previous number is going to become 4, and decimal number, 1 decimal place means 4.0. So next is you're going to add these 3 kgs to the decimal numbers. You get this answer. Locate the least decimal number, which is 1 decimal number. So then you have to round it off to 1 decimal only. So you're dropping off a 9 in this case, so the 7 becomes an 8. And 1 decimal number, so put 0.0. Subtracting these 2 numbers, locate the least decimal place, which is just 1 in this case. So you subtract as usual and round it off to 1 decimal place, which means you're dropping off a 6. The previous number can be increased by 1. This is in the case of addition or subtraction. Whenever they ask you to write it as this appropriate significant figure, it is about locating the least decimal place. But when it comes to multiplication or division, look at the multiplication I've done. You have to locate least significant figure and round it off to least significant figure. That's something you need to memorize. Least significant figure is just 2 significant figures. So your answer has to be rounded off to 2 significant figure, which is just 4 and 8. So replace rest of it as zeros so that it's closest to the significant figure. So multiplying and dividing is still the same. Locate the least decimal place, which is 3. So your answer can have only 3 decimal place. So you're dropping off a 1. So it's just 0.115. So in this case, multiplication and division, you just solve the powers, you get this answer and you get this as the answer, and locate the least decimal place. As I said, the powers need not be taken into account provided there's no unit. If this does not have any unit, you don't have to bother about the zeros in the future or zeros in the past, because both of them are non-significant. Just solve the 10 to the power minus 4 and 10 to the power 7. Multiply and write the answer. Round it off to least decimal place, which is 3. Least significant figure. So this is multiplication and division. So least significant figure, which is 3. But dropping off a 7, the previous digit makes it 2. Add 1, 10.2, 10 to the power 3. Then you have a cube whose one side is given as 7.203 meters. They're asking for surface area, which is 6a square. Calculate the value, and its multiplication division least significant figure is just 4. So you have to round it off to 4 significant figures. So you're dropping off a number which is 9, which is greater than 5. So previous number has to be increased by 1. in the calculating volume, which is a cube. While doing so, you should have the least significant figure, which is 4. So taking a 4 digits into account, you're dropping off a 1, so previous digit can remain as it is. Then I taught you the difference between accuracy and precision. They have given the original mass of a body to be 0.5209 or something, okay, 0.52. I think it's 0.520 grams. That's the original mass that's printed on a body that you're buying from the shop, which is called the true mass. Okay, and when you measure it in the lab, when you bring it to the lab and measure it, you can make errors. You might get different value. A student A is measuring these values 0.5 to 0.51, 0.50, 0.51 grams. A student B measuring the same, he is getting 0.516, 0.515, 0.514, 0.515. This shows that he is measuring it using a different instrument, because the least count seems to be different in this. It's got 3 digit measurements, decimal digit, whereas here it's only 2. So student C is measuring it and is getting this value. And accuracy is the closest of the measurement to the true value. The closest it gets to the true value is known as accuracy. And precision depends on the least count of the measuring instrument. So if this reading, which is both accurate and precise, is the one which is made by C, because precision needs 3 digits, is also closest to 0.520. When you do the average of this, the average value has to be closer to the measured value, that's called, or the true value is known as accuracy. And precision depends on the least count, which is basically the 3 decimal places, which involves an instrument change. See, for generally you should know the instruments such as screw gauge, a vernier caliper, and a meter scale, or the 3 ways in which you can measure. If you want to measure a diameter of a thin wire, we prefer screw gauge because it has got least count, which is much lesser. It's able to measure smaller things with more precision. A vernier caliper is like this, an apparatus like this in your lab. Please go and check with your teachers. In your school, you can, if you want to find the diameter of the bob, metal bob, vernier caliper can be used. And if you measure it with a meter scale whose least count is millimeter, in the case of meter scale, it need not be more precise. So that's what it is. Imagine the screw gauge has got a least count which is 0.01 millimeter, whereas a normal scale has got 1 millimeter as a least count. So can you see? And vernier caliper, the least count will be 0.1 millimeter. So then, depending on what you want to measure, you choose the right instrument, it will lead you to a precise value. And errors can be avoided. So thus giving rise to a topic called errors. What is an error? See, I'll generally tell you, for you to understand what is an error, you go to the lab and take your spring balance. Okay, a spring balance consists of a spring and a pan, and you have a meter reading in which there is a pointer. If the pointer is going to be in 0 exactly, and when you add weights, a 3 kg weight, it will drop down to 3. It is a beautiful spring balance which is very, very accurate in measuring. But however, over usage over long years, you see the pointer may sometimes be above 0 or the pointer may sometimes be below 0. Supposing it's already at 1 and I'm adding a 3 kg weight, it will show a measure of 4. So I have to subtract 1 if the pointer is below. If the pointer is above, I'll have to add 1. And so supposing if it's the above and if it's 3 kg, it will show you reading 2. So therefore, you know that the true value plus or minus 1, where the plus or minus 1 in this case is the error. So that's one simple error that I can teach you. So then error is true value minus measured value. The different types of errors: one is a constant error, a systematic error, random error, and least count error. These are the theories which you should study. A constant error is which affects the observation always with a constant value. A systematic error can be instrumental error, as I told you, the 0 error in the instrumental error imperfections in the experiment, a personal error, you may be distracted, you may be sleepy, or your eyesight may be a problem, external causes such as wind, you're putting on the fan and doing the experiment. No, then and there are random errors. Random errors, you can make random mistakes like that, silly mistakes like that, random errors is possible. A least count error, as I told you, you have to choose the right instrument with the proper least count. Okay, so in order to get more precise values, these are the errors that can commonly exist. Those are theory. So then is about errors. So let's learn errors for entrance exams, because most of the schools do not have errors. You have two resistances, R1 is 100 plus or minus 3 ohms, where this is the error. As I told you, it can be plus or minus 3. A resistance 2 is 200 plus or minus 4 ohms. An equivalent resistance in series is R1 plus R2. You plug in this value, first resistance, second resistance here. And when you're adding the two values with errors, you add the true value. We write a plus or minus and add the errors with a plus. Why is it not written with a plus or minus? Because we always need maximum possible errors. The error part should always be written with a plus, even though there's a plus or minus here, which obviously you know. The errors in itself, the 3 and the 4 should be written with a plus. In next question, again 2 masses have been given with errors. You're going to find the total mass is M1 plus M2. Add the true values and then add the errors. Don't subtract the errors, because we want maximum possible errors, again with a plus or minus, and that's what happens in adding of two errors. Then subtraction of two values. Subtracting two temperatures, T2 minus T1, subtract the two temperatures, true value, but add the errors. Never will we subtract errors with a plus or minus. So then this is involving division. They ask you to find the resistance. They've given voltage and current, and R is equal to V by I. While calculating, there are two things that you should know. Delta R by R is called fractional error or relative error. A delta R by R into 100 is called percentage error. Okay, so in this question, find the percentage error. So write the formula for percentage error. The R will become delta R by R into 100 is equal to delta V by V into 100 plus delta I by I into 100. Even though it's division, you have to write it only with the fractional error only with an addition symbol. Okay, I taught you a proof for it. See, look at this. Z is equal to A by B. A is one value and B is the true value of it, and you're dividing it. With an error, Z is equal to plus or minus delta Z. A becomes A plus or minus delta A, B is B plus or minus delta B. From this, take out A common and B common, and A by B is the real value. It will become delta A by A plus 1 plus or minus delta A by B, 1 plus or minus delta B by B. So you know that equating the left side and the right side, the Z is nothing but A by B from the first equation. So you can cancel it, and you have to take this up using exponents and use binomial theorem, according to which the minus 1 comes in the middle. So it will become plus will become minus, and a minus will become plus, it will become minus or plus. And then take it inside and multiply. This can be ignored because two fractional errors, when multiplied, becomes two fractional, such as 1 by 2 into 1 by 4 is 1 by 8. It's becoming lesser. So ignore it and write it. 1 and 1 get cancelled. Z is already cancelled. Already got cancelled. 1 and 1 cancelled. Thus you get a new formula. Plus or minus delta Z by Z is equal to plus or minus delta A by A plus or minus delta B by B. But maximum possible errors are what you're supposed to write. So ignore the plus or minus and write this answer. So you see that even though B was in the denominator, when doing the errors, it comes with a plus. So that's exactly what I've done here. It's delta V by V into 100 plus delta I by I into 100. Where they've already given the percentage error. Have they given the percentage error? They've given it as 5% and 0. No, they've given it as no, they've given only errors, not the percentage error. The 5 and the 2 volts are the errors. Substitute that in the error. Error is this delta V is the error in voltage, and delta I is the error in current, which is 5 and 0.2 respectively. And plug it in this formula. you'll get the total percentage error to be 7%. Similarly, that's the proof that I taught you for it. And for addition, you're going to add the real value with plus or minus, add the errors. The proof is this. You can understand how I've written it with the errors, and how you take z and z and cancel it. When there is a power, you have to memorize this because this involves differentiation. I have not taught you differentiation. When there is a to the power p, right? P into delta A by A being the fractional error. When there is a q in the power, is q into delta B by B. And this r in the power is plus, because denominator c is there, doesn't mean it's minus. It is on everything with the plus r into delta c by c. And these are called fractional errors or relative error. Relative error is a change in error to the original error. Okay, but a percentage error is multiplied throughout with 100. So errors involving, they have given errors involving a side is 3%, errors involving mass is 4%. Asking you to calculate the error in the density, which is mass by volume, is L is given, side L is given, so L cube, the power is involved. So it's delta M by M into 100 plus 3 into delta L by L into 100. And you know the percentage errors, which is given as 3%. For mass it's 4 plus 3 into, for side it's 3. Just calculate and write this answer. 4 plus 9. The error in measuring the radius is 2%, which means percentage error in measuring the radius delta R by R into 100% has been given to be 2. They're asking you to find the error in the volume, which is 4 by 3 pi r cube, where 4 by 3 pi and all will not have errors because they're constant. So it's delta V by V is equal to 3 into delta R by R. In terms of percentage error, multiply with 100, and this value itself is 2. So the total percentage error in measuring the volume is just 6%. A percentage error in measuring the mass is 2% and speed is 3%, which means delta M by M into 100 itself is 2. And delta V by V into 100% itself is 3. Kinetic energy's formula is half mv square. Half can be ignored. It's not going to contribute to any error. So fractional error is delta K by K is equal to delta M by M plus 2 times delta V by V, and multiply throughout the 100%. Substitute the value on the first equation and the second equation, and here you get the total percentage error. So therefore you understood what happens when there is a power. So when there is 4 into delta A by A plus 1 by 3 into delta B by B plus power is 1 into delta C by C plus 3 by 2 into delta D by D. All of them should be written only with plus, even though there is division, and you can throughout multiply with 100 if the percentage error has been given, and they're not just a question of substituting the values if it's given. Similarly, in this sum you see it's a to the power 2, which is 2 into delta A by A, b to the power 3, which is 3 into delta B by B, by C doesn't matter, it's delta C by C, and d to the power half means plus half into delta D by D, and D by D. And writing this formula, multiplying throughout with 100% because the percentage error of all these values has been given. Just substitute the value and get the answer. So these are the sums that I've dealt with. This I'm saying next chapter, after teaching the next chapter differentiation, I'll teach you resistors in parallel. This is what I took yesterday. Please be clear with